Okay, so now that we've talked about all the types of transformations we could have, let's review how those transformations look with our 5 basic shaped functions. So our quadratic function, f of x equals x squared, when we put transformations on it, it will look like f of x equals a parentheses x minus h squared plus k, where the a is reflection, stretch, or compress, the h is a horizontal shift, and the k is a vertical shift. The square root function, which the basic parent equation is f of x equals the square root of x, if I add some transformations on it, it'll look like a times the square root of x minus h. Notice the x minus h is underneath the radical, then plus k. Again, the a, h, and k are the same transformations as they were in the quadratic. A is reflection, stretch and compress, h is horizontal, and k is vertical. The next one is absolute value function. The a would go in front times the absolute value of x minus h plus k. For the cubic function, the equation with transformations looks like a parentheses x minus h, this time cubed, plus k. And then the last one, the cube root, is a times the cube root of x minus h plus k. Please note that all the transformations for all of these basic shape functions are really similar. The h is always with the x, it's always inside the parentheses or underneath the radical, so that one is your horizontal shift. Remember, that's opposite of what you might think. We're just going to put opposite over here, because it's a minus in the formula, so the h is going to go the opposite direction. Now the k goes exactly like you'd think it goes, but it's a vertical shift. That's not opposite whatsoever. If it says plus, it's going to go up. If it says minus, it goes down. If you put those two letters together, hk, you get the vertex. So the a does a couple different things. It does the reflection if a is negative. It's also a compression if a is between 0 and 1, like a half, or it's a stretch if a is greater than 1, for example, 2. Okay, so the a does several different things here. Next, let's talk about the steps to graph with more than one transformation. So first thing I want you to do is determine the basic shape of the graph. Once you've determined the basic shape, then I want you to find the horizontal shift, which is the h. Now I gave you an example problem up here. The h is always the letter that's with the x inside the function, and it's opposite of what you might think because of the minus in the formula. The vertical shift is k, and that's on the outside of the function being added. Use those two things to find the translated vertex. Because the vertex used to be at the origin for the parent function, we're now going to translate it h and k to get a new vertex. Now I want you to use the stretch and compress, which is a, to find new key points in relation to your new vertex. Connect all your points, make sure your graph looks like the basic shape. Just because you have your correct points there, doesn't mean you have the correct shape, so you got to make sure that it all looks right. So let's practice this. On our first problem, we have f of x equals negative 2 x minus 3 quantity squared minus 4. So because of this squared here, I know it's a quadratic. If you want to think about your parent function with its transformations, if I'm trying to find the basic shape, I know that's a U shape because it's a quadratic. My horizontal shift will be the h, in this case a positive 3. It's opposite of what you think. My vertical shift is exactly what you think. It's the k, which in this case is -4. Note it's not opposite. Put those two numbers together, 3 comma -4, that's your vertex. And the compress and stretch is your a. So just put whatever number is there. In this case, -2. -2 means both. Because there's a negative, that means there's a reflection. And because 2 is greater than 1, that's a stretch. So the 2 makes it a stretch, the negative makes it a reflect. But we're going to remind you how to do that in just a minute, okay? So when I go to plot my points, I'm going to first plot my vertex, +3, comma -1, 2, 3, 4, right there. Okay? Now, go back to your basic shape. The reason we drew this here is so that we could remind you how to get your key points. I always go left and right 1 and up 1 to get my new points from my parent shape. But when I do a compress and stretch, my left and right 1 will always stay the same. Always, always, always. It's the vertical part. Because this is not just any old compress and stretch, it's technically a vertical stretch and compress. Because it's a vertical stretch and compress, my left and right 1 will always stay the same, but these numbers right here, when instead of going up 1, I'm going to go up or down the -2a piece. So to be clear, because there's a -2 here, from my vertex, I'm going to go left and right 1, up or down the a, whatever the a is. And in this case, I'm going to erase that a and put actually -2. So I go left and right 1 from my vertex. So I'll start left 1, but instead of normally I would go up 1, I'm not going to do that. I'm going to go left 1 and down 2. Why do I go down 2? Because my a is -2. Normally I would go right 1 and up 1, but I'm not going to do that this time. I'm going to go right 1 and down 2. Why? Because my a is 2. So left and right 1, down 2. Last step is to connect your points with the basic shape. I know this is a U shape, but because it's pointing down, I just flip it over. That's the reflect. So not only did this get reflected and it's pointing down, but it also got stretched out. It's more narrow than what it would have been. Our next problem is a square root problem. The parent function for that, with its transformations, would be a times the square root of x minus h plus k. So I have my h, my k, my hk for my vertex, and my a. So my h in this case is going to be -5. The opposite of whatever's in the function, adding or subtracting to the x. So in this case it's x plus 5. I take the opposite, which is -5. The vertical is the one outside the function, and that one just comes straight as is. There's no minus on the k in my function, so we can just keep those. Put those two numbers together, -5, 2, to get your vertex. And in this case, my stretch and compress is 1/2. Don't forget that this is always a vertical stretch and compress in this class. Technically, there is a horizontal stretch and compress, but we just don't cover it in this class. All right, what is the basic shape? Well, the basic shape of a square root function looks like this. And I'm going to get points for all of these blanks onto the right side, but to get all of your points, you need to graph the whole thing. So I can plot my vertex at -5, +2, and then I need to get my key points, my critical values other than my vertex. So the basic shape of a square root, normally all I do is get right 1 and up 1, which would be my parent function's key point. But instead of going up 1, I'm going to now go up 1/2. So I'm going to take that 1 out and put 1/2 instead. Why? Well, because my compress and stretch is 1/2. To be clear, I'm going left and right 1, because I always go left and right 1, and I go up or down a half. In this case, there's only one key point, so I'm actually only going to be going right 1, and I'm going to be going up a half. Right 1 and up a half will be right here. So now we're going to connect it with its basic shape. It still looks like a square root function, but it's not quite as tall as it was in the past because my 1/2 is a compress. I'm going to be compressed towards the x-axis, and it's going to look like it's been squashed. So it's going to look like it's been squashed or sat on or something like that.